Hi everyone, today we're going to talk about solving quadratic equations by this new method called completing the square. Before you get started, if you need to pause this, go ahead and pause it. Make sure you have the guided note sheet that I sent to you. You can write your notes right on there. The examples that are on there are going to be the same examples that I'm doing here. If you need at any point to pause the video to catch up, go ahead and do that. If you need to rewind it to kind of go over something again, feel free to do that as well. So this is a new way of solving quadratic equations. We talked about solving them by factoring and by graphing, but this is another way of doing it. So before we get into the actual completing the square, I do want to do just a quick little review of equation solving. And you'll see the two different equations that are up here. These are the same problems that are on your sheet. And you'll see that they're a little bit different. The one on the left has an x squared in it, and then the rest of the values in that equation are just regular numbers. If you see this equation over on the right, there's an x squared term, and then there's also that negative 10x in there. So they're a little bit different, but we are going to solve both of them. So let's look at the first one here. So because we only have this one x term in here, I'm going to move all of my other terms to the other side. So I'm going to go ahead and add 4 to both sides. And then I end up with 3x squared is equal to 72. And then I need to solve for x. First thing I need to do is isolate that x squared term. So I'm going to divide both sides by 3. I end up with x squared is 24. And then in order to solve for x, I need to take the square root of both sides. And so when I do that, I end up with x is going to be equal to plus or minus the square root of 24. Remember, when I have an x squared terms, I should have two solutions. And from there, then I need to simplify my square root. And this is going back to stuff that you did before. Right? Find your factors of 24. I'm going to use 4 and 6 as my factors. 4 is a perfect square, which can come out from under the radical. The square root of 4 is 2. So I'm left with plus or minus 2 radical 6. Okay? Or 2 square root 6. So that's how you go about solving it when you just have the single x term in it and it's squared. This one over here is a little bit different because I have that 10x term in there. And so what I'm actually going to do is I'm going to factor this side of my equation. And when you factor that, you should recognize that this is the square of a binomial. Now, if you don't recognize that, remember, whenever you're factoring a trinomial, you're looking for two numbers that add to that middle term and multiply to that last term. My numbers would be -5 and -5. So when I go ahead and factor this, I end up with x minus 5 times x minus 5. And I can actually rewrite that as x minus 5 squared. And that equals 27. The only difference between the problem here on the left and the problem here on the right is that on the right I have this binomial squared, where on the left I just had x squared. But I'm going to go through and solve it the same exact way. To solve for x, I'm going to take the square root of both sides. And so when I take the square root of something that's squared, I'm left with just what was squared, which was x minus 5. Because I'm taking the square root, I need to do plus or minus on the right-hand side, so I end up with x minus 5 is equal to plus or minus square root 27. Add 5 to both sides. It can't go under the radical because they're not like terms. So I end up with x equals 5 plus or minus the square root of 27. I know I just did a bunch of stuff there, but it's very systematic. Factored. I wrote that as the square of a binomial, and then I took the square root of both sides, added 5 to both sides to get x by itself. The only other thing I have left to do is to simplify what's under the radical. My factors of 27 are 9 and 3. 9 is my perfect square, so I end up with x is equal to 5 plus or minus 3 radical 3. And that is my final answer for that. So take a minute, look that over before you move on with the video. Okay, so now we're going to talk about completing the square. And the idea of completing the square is this. We are looking to create a trinomial that is the square of a binomial. So think back to the problem that we just did. I had x squared minus 10x plus 25. And I was able to write that as x minus 5 squared. Okay, that is the square of a binomial. Binomial is 2 terms. But remember, I had a trinomial and I wrote it as the square of a binomial. And I'm going to do the same thing down here. And all I have to do is this. It's very straightforward. As long as what's in front of x squared is a 1, and remember, if there's nothing written in front of x squared, then it's assumed to just be 1. So we're okay in this problem. I'm going to look at that middle term, or that b value, right? Remember the general form was ax squared plus bx plus c. We talked about that last week, okay? So I'm looking at that b value. What I'm going to do is I'm going to take half of my b and I'm going to square it, and I'm going to add that to the end of my equation. Okay, so I'm going to take half of b and square it. So half of negative 8 is negative 4. So I'm going to take half of negative 8, which is negative 4, and then I'm going to go ahead and square that, and that gives me 16, and that's completing the square. Okay, so take half of b, square it, and that's what you put in. That's completing the square. So come on over here. I have a 5 here. Okay, I'm going to take half of 5. If I take half of 5, and trust me, it's easier to leave it as a fraction. Do not do it as a decimal because that's going to make it a lot harder. I'm going to take half of 5, which is 5 halves, and then I'm going to square that. When I square a fraction, I square the numerator and I square the denominator. And that's what goes here. And I know people hate to see fractions, but trust me on this, it's going to be way easier to leave it as a fraction. Okay, so that is the process of completing the square. That's what it means to complete the square. And now I'm going to show you how we use that in problems, or how we use that to actually solve for x. Now, I'm going to go ahead and I'm going to solve the quadratic equation by completing the square. So, look at this first one here. On the left, I have x squared equals 27 minus 6x. The first thing I want to do is I want to get all of my x terms on one side of my equation and get everything else on the other side. So I have to add 6x to both sides to get it in the form that I need. So I have x squared plus 6x, and then I'm going to leave a space because I have to complete the square, and I'm going to leave the 27 on the other side there. Now, again, to complete the square, I take half of that b value. So half of 6 is 3, and then I'm going to square that, and that gives me 9, so that's what is going here. In order to keep it as an equation, whatever I do to one side of the equation, I have to do to the other side. So since I added 9 to the left, I have to add 9 to the right in order to keep my equation, to keep it an equation, to keep equality. To maintain equality, I have to do to one side what I did to the other side. Okay, so now look at this trinomial that we have here. Right, I've got x squared plus 6x plus 9. I can actually write that as the square of a binomial. That's what I'm trying to do, is complete the square. I need two numbers that add to 6 and multiply to 9. Those numbers would be 3 and 3. So I can write this as x plus 3 squared. Okay, so this is a really crucial step. You're looking for that number, those two numbers that add to 6 and multiply to 9. So you're always going to have that same number in there. That's what it means to complete the square. You should end up with a single binomial. And let's then look at the other side. 27 plus 9 gives me 36. Okay, and now in order to solve for x, and now I'm going to go ahead and I'm going to take the square root of both sides. And when I take the square root of something that is squared, I just get back what I started with, which is x plus 3 by itself. And because I took the square root of this, I have to take plus and minus because I will always have two answers. Square root of 36 is plus or minus 6. Okay, and then I'm going to solve. So subtract 3 from both sides, so I have negative 3 plus or minus 6. Which just means I'm doing negative 3 plus 6 and negative 3 minus 6. So negative 3 plus 6 would give me 3, and negative 3 minus 6 would give me negative 9. So those are my two solutions, 3 and negative 9. Because it's a squared, because it's a quadratic, I should have two answers. Okay, that's what it means to solve by completing the square. Let's try another one. I'm going to actually do the second one on the next sheet, but it should be on the same sheet on your page. Okay, I already have the x terms by themselves on this side of the equation. However, I have this 2 in front, and I can't do what I need to do with that 2 there. So I'm going to go ahead and divide everything by 2. Whatever I do to one side of an equation, I have to do to the other. So I end up with x squared plus 4x, and I'm going to leave a space, is equal to 6. And now I'm going to complete the square. I'm going to take half of 4, which is 2, and I'm going to square that. So I'm just going to write that in here. I'm going to take half of 4, and then I'm going to square that. So that leaves me with x squared plus 4x plus 4 divided by 2 is 2. 2 squared is 4. Now I have a trinomial, which I can write as the square of a binomial. Two numbers that add to 4 and multiply to 4 would just be 2. Okay, take the square root of both sides. When I take the square root of a binomial squared, I just get back that binomial. I have to take plus or minus on the other side, and I'm going to subtract 2 from both sides. And I end up with negative 2 plus or minus the square root of 6. Take a minute if you need to, and then you can pick up again. So this is the last problem we're going to do. Because I'm short on time, I'm going to kind of go through this a little bit fast. So I want to write this in vertex form. So I'm still going to complete the square, and here's how I'm going to do it. I'm going to leave a space here so I can complete the square, and then I'm going to just move my negative 13 over. And here's what happens. I'm going to go ahead and complete the square here, which means I'm going to take half of 10, which is 5, and I'm going to square it. Square 5, I get 25. Okay? Because I added 25 to my equation, then I also need to subtract 25 from my equation to keep that same equation as it was. I don't want to alter it. I don't want to alter the value of it. This is the square of a binomial. That binomial is x plus 5 squared. And then I have negative 28 here. You should recognize this as the vertex form of a quadratic where your center is at HK. Remember, take the opposite sign of what's inside the parentheses and the same sign as that K term, and that would give you the vertex of your parabola. And that is your vertex form. I went through that quick, so go back and review it. Thanks, everybody. I'll see you next time. Take care.